Welcome. I'm James. Nice to meet y'all. I will hopefully at some point learn most of your names. Let's kind of go through the details of the class logistics, and then we'll talk about math. By the way, just make sure everyone's in the right place. This is for 16A, not for 17A. If you're enrolled in 17A, there's a class after this in a different building that you should attend. Cool. All right. So this is Co-16A. Let's look at the Canvas for it. I will say things are pretty straightforward. There's not a whole lot of details you have to be aware for this class. There's a couple things you need to know, but mostly you're just going to come here. We're going to talk about math. I'm going to show you some stuff. You're going to do some problems. Hopefully we'll be writing on a nicer thing than this, but this might be what we're stuck with. So let's go over the syllabus real quick. Syllabus, I'm going to change the homepage at some point to be the modules, because that's where you'll actually find anything useful about this class, in my opinion. But for now, we'll start off in the syllabus. Let's do it. So class, you know when it meets because you're here. You're encouraged to come to class in person. You can come via Zoom. You can also watch the class later if you can't come in person, as already some people have emailed me that this time just doesn't work for them. That's totally fine. As far as reaching me, there's a number of ways to reach me. The best way is usually email. You can also find me in my office occasionally. You could call my phone if you really wanted to, but you'll probably just get my voicemail, which I'll respond to eventually. Email is best. You can also find me in office hours. They are many and varied. Mondays and Wednesdays from 1 to 2 in Math Drop-In. Tuesdays and Thursdays from 3:40 to 4:30 in Math Drop-In. Math Drop-In is in the lower level of the library, Shields Library, and it starts October 8th. So that's when the office hours start. And then the other two, Mondays and Wednesdays from 10 to noon and Fridays from 10 to 11 in C class, where anyone is welcome. It's the Center for Chicano Latino Academic Student Success. Those office hours start on Monday, October 3rd. Same for the Tuesdays and Thursdays from 1:40 to 3:30 in CADS, which is the Center for African Diaspora Student Success. Anyone is welcome in either place. You can find me there. Usually that is an ideal place to find me if you're looking for help, because there are usually less people looking for me there. So if you really want more individualized attention, come find me there. I'll just be sitting around doing nothing until someone shows up. So yeah, and I'll be starting Monday and then drop-in starting the following Sunday. How this class is graded. It's pretty straightforward. This class is a pass, no pass class. A passing grade is 75% or higher. There are two components to your grade: attendance. Oh yeah, attendance. And sure, let me do this real quick. Attendance, which you can fill out by scanning this QR code. Nope. Really? Disappointment code. All right, well, here, I can just pass it around. You can scan this, fill out the attendance one. It's pretty easy. I would appreciate it. Make sure you scan the one with attendance, not office hours, which is on the backside. What I would honestly recommend, though, is bookmarking the link, because you'll need to do this every time you attend. Whether or not you've actually registered for the class or you have enrolled via the Google form, you still need to fill this out, because we need to track all the data, because that's part of how we get funded. So please, please, please fill out the attendance form every time you attend, because it is important to our department, aside from your grade.
If we can't make it and we go on like Zoom, do you still fill
Yes, so whether or not you, in fact, let's actually all take a look at the attendance form together. Of course, I didn't link it there because I'm brilliant. Let's go to the modules where I know it's linked. Bless you. So this is what the attendance form should look like. Exciting. And it's pretty straightforward. You'll put your email in there. You'll put your student ID number there. You will fill in your name just like you would usually write your name. Here's how I would write my name: James Parmenter. No commas, no anything special. If you're done with that, you can hand it back to me. Do try to write your name how it is written in Canvas. Just because I would just sort these alphabetically by first name, just to make it easier to enter them into Canvas. And then you'll click the class you're attending, which is Co-16A. which way you attended, and then importantly, the date that the class you are attending for, not the actual date it is. So for example, if you were watching this video tomorrow, because you couldn't make it today, which is totally fine, you should still fill out the date of 9/28, right? Today's 28th? Yes, you should still fill out the date of 9/28/2023. Do you try to get the year right? If you get the year wrong, it like puts it in some weird place and I have to just fix it, but it's a pain. Of course, yes. And so again, what I would highly recommend is bookmarking this page, because you're gonna go to it every time you fill out the attendance form. And it's easier than having to go to Canvas and click on it or whatever. So that's 70% of your grade, and the other 30% is doing the weekly reflections. This is something that I stopped doing for a while, but I brought back because I found that there's a lot of value to it. They're really easy. This is not something that's supposed to be hard, something that's for me really to just kind of get a feeling of how the class is going. So let's just look at the first one, for example. Here's what I want you to do for the first one. Tell me your preferred name, your hometown, or place that you consider yourself to be from, the best or worst movie you saw this summer, what was the last math class you took in college or high school, who was your teacher for 16A, and always optional, but always appreciated, jokes, memes, other things. All right, so really, like, there's no math here. I really just want to know, like, how you think you're doing, stuff about you, occasionally something silly. If you got jokes, I want to hear them, but really not that hard. I gave kind of a small window for doing it. I might change that. So this becomes available tomorrow at 4 p.m. because the idea is you'll do it after you had a week of classes each week. So it'll be available like Friday at 4. And I think it's due Saturday at 4, but then it's like open for a whole week after that. So just try and do it timely. Back to the syllabus. So that's it as far as grading. Attendance, the other thing, which I can't remember the name of, weekly reflections. Try to fill out the attendance form in a timely manner. I've definitely had people at the end of the quarter be like, fill out like 20 attendances. I'm like, come on, dude, just fill it out on time. What else? If you're absent from class, you can make up a class by watching the recorded video and then filling out the attendance form. And then not passing a no pass workload class is not the end of the world. Everyone can pass. It's not hard to pass. You just have to do the things. Questions about any of that? Okay. So the rest of this is kind of just things I should say, but are not that important. If something is impacting your success in math, please don't hesitate to talk with me about it. I want to be a resource. If it's me that's impacting you, let someone else know, or you can tell me if you feel comfortable, but also there are places to report like the AATC feedback form or the Academic Retention Initiative Centers. If for some reason I'm doing something crazy, that's not very likely, but I don't know, I'm not you. So maybe I said something terrible and I didn't mean to. I don't imagine that happening, but there are other places you can seek help if I am somehow not great. That's when our class is. As far as how class goes, I'm going to show you examples. I might have you work on stuff. I will say in the last 3-ish years, the format of this class has kind of unfortunately evolved into me talking more because I'm also trying to make a recording that students can watch later. That said, I will still try to find time to have you work on problems either individually or with each other because I think that is very beneficial. Honestly, that's how you really learn math. You learn math by doing math, not by having someone tell you math. So I will try to be giving examples, but also letting you think about stuff on your own as well. As far as accommodations, if there's something I can do to improve your ability to succeed in this class, let me know. You're probably not the only one it would be helpful for. That said, in the same sort of vein, if you have a question, you should ask it. Yesterday, there was someone who I could see was just like, couldn't quite get there. She really wanted to ask a question. She was like, and finally I was like, does anyone, like, really, any questions? Finally, she like had the nerve and asked. I don't remember what it was, but like there were like 5 other people who were like, oh yeah, I'm glad she asked that because they wanted to know the answer too. So please, if you have a question, even if you think it might not be super helpful, it probably is. And then if you have any formal accommodations to the Student Disability Center, please let me know. They probably won't really make much of a difference in this class because there's no tests or homework. I do record everything already. So usually those are usually the things are like people needing extra time or needing recordings. I don't think either of those things really matter in this class because there are recordings and there are no tests, but please let me know anyway. I'm happy to accommodate whatever accommodations are needed. We're all pros at Zoom by this point, but you're welcome to attend via Zoom. The link should be right at the top of the syllabus right there. And then what else? Zoom. Some notes about this class. It carries one workload unit, which means it counts towards being full-time and towards whatever financial aid you have, but it does not count towards graduation or your 225 unit cap. So that's what that is. I've tried to encourage every quarter students to use the discussion tab in Canvas to ask me questions or also to have conversations with each other, but no one ever really is. You could make like a class Discord if you wanted to. I know there's one for Tavernides class, right? So, but you're welcome to do whatever you like. If this works for you, great. I do respond relatively quickly. The cool thing about the discussion tab and actually Canvas in general is there is a way to write in a nice mathematical typesetting that I'm very familiar with. So if you ask math questions, I can write back in a way that looks nice and is easy to read. What else? Yeah. Each unit in the course is connected to the other units. Math builds on itself like it always does. You learn something and then you learn something else. You're like, oh, we use the thing we just learned. Yeah. Successful students usually spend 10 to 20 hours per week doing homework, practice problems, and studying for Math 16A outside of class. You can count these 2-3 hours a week as part of that, but still, there should be a significant amount of time outside of this, outside of attending lecture, where you're doing math, which is good, I think. I mean, as you might have already surmised, I like math a lot. I mean, I teach math. I'm a big fan. I could talk about it for days and days and days. I'll try not to talk too much. Where can you get more help? My office hours. Grant's website is always a great resource. He's one of my coworkers. He has lots of materials on his website. I encourage you to check it out. Then there's the AATC tutoring page. You can find where the drop-in hours are again. You can also make individual appointments with student tutors. And then each other. You all are a great resource to each other. I encourage you all to get to know each other because I think it is worthwhile and you should study with each other. Honestly, like that is where you will do a lot of learning. Quick question. How many of you are in Tavernides class? Majority. How many of you are in Temergalavia's class? I think that's how you say your name. One. Raise them high so I can see. Just one? Okay. Two? No? Okay. All right. Well, good to know. They're both perfectly good teachers. Let's see. Let's go over to so the modules are actually where you're going to find anything useful. Oh, let me move this out of the way here. Kind of. So this you can't see yet. This is the course evaluation I'll have you at the end of the quarter. Useful links. We've already kind of talked about them, but the link to the attendance form, the link to the Zoom. Here's the link to the playlist on YouTube where I will post the video recordings. I will also probably post them in Canvas, but it's easier to post them on YouTube. I post them on YouTube first, then link them. Class notes will be in Google Notes where you can see whatever I've written down. I will post those as well. You can find my office hours, Grant's website. And then here's actually something worth looking at. Oh, come on. These are some videos that my colleagues and myself made a few years ago that just have kind of short videos by subject. So like you can look here, they take a minute to load here. We'll come back to that. But eventually you can see that there are videos here about the Cartesian plane, distance formula, midpoint formula, graphs, intercepts, circles, and lines. So if you want more instruction that is not like a super long video like the class recording, there are some good ones here. Claire, Sarah, Grant, myself. I don't remember who exactly made which ones, but I definitely, if you're looking for more instruction, this is a good resource. And again, you can find that right in the modules. Right there. And then my website is trash. You shouldn't go look at it. There's nothing there. There's my office hours and the classes I teach and a picture of me and my cat, and that's about it. Oh, and then there's some derivative worksheets, which are not available yet because we haven't talked about derivatives yet. And then here's where I'll put exam study materials. And I'll probably make another module here where there's the videos and the class notes, just so you can have them easily accessible. That's terrible. Would love temperature warning. That's interesting. Okay. Questions? Cool. So for those of you that can't register for the class or don't want to register for the class, I am happy to add you to Canvas. All you need to do is send me an email. Or actually, you can do one of two things. The easiest thing is just to send me an email and I'll add you. The other thing you can do is you can go to, although it's, I don't know why you would, but you can go to the tutoring.ucdavis.edu page, go to the math section, scroll down to the classes, and then you can click on this registration form and fill out the Google form, and then my boss will send me an email with all the people that have done it. The only thing about that is if you accidentally write your email wrong, it'll get added wrong. So the easiest way is just to shoot me an email. My email is jjparmenter@ucdavis.edu. Let me write that up here. JJParmenter@usual. So yeah, if you're not already on Canvas and you want to be and you don't want to register for the class, shoot me an email and I will happily add you right away. Totally. So if you drop the class, though, you will need to email me so that I can add you back to Canvas. Yeah. Whether or not you are actually registered for the class and getting the one workload unit or added to Canvas via the Google form, I do ask that you all please fill out the attendance form. Every time. It's not that hard. It's like you write a few things. I know you all can do it. Do it for me because you like me. Okay. Other questions? Oh, God. Ugh. Okay. So I noticed that almost all of you, oh, what's up? Sorry.
I just wouldn't get a grade.
Right. Which would be pass, no pass. And even then it's only one workload unit. So it doesn't really, in the grand scheme of things, the one workload unit doesn't really count for anything. The one thing I'll say is like, if you are like right on the edge of 12 units, then you should take this class for your unit so that you can get the unit to be meeting minimum progress. But otherwise it's kind of, I was gonna say, so almost all of you are in Tavernetti's class. And I know he assigns homework, but does not collect it, which is unfortunate. I understand why, right? There's lots of people taking this class, a lot of homework to collect. But you really can't stress enough how important it is that you all do all the homework all the time. Please, for yourself, make sure you do the homework. Even if it seems easy, it's still good practice. All right, I think that's is that about it? Let's see. Let's see if there's anything else in Canvas I can talk about before we get going here. Close that. Hey, what's up?
I have a question, and you might not know it.
Sure.
In regards to the grading, but do you know if Dr. Tav's class is curved?
So what I read on his website was that essentially the curve will only be beneficial.
Okay.
So he might, if you know, if like let's say the class average is a 60, then that'll be a C or whatever. I don't know what, but like it won't be like if the class average is a 90 whatever is still going to be an A, right? Like he's I think he said it wouldn't be like retrograde or something like that. Like basically the curve won't screw you. The curve is only going to help you. It's never going to hurt you, at least in his class. Yeah.
Will we go over like homework problems?
Total. So we can go over homework problems, especially since they're not being graded. I have no compunction about going. I mean, usually I don't really care anyway, because honestly, you can find answers to homework problems anywhere, right? Like, so, but especially since they're not part of your grade, I have no worries or cares about going over them or not. So happy to go over homework problems, happy to go over problems similar to homework problems, all that kind of stuff. Other questions? There was something else I want to say about just so you're aware. I don't know how familiar you all are with Canvas, but one thing I would point out in case you didn't already know is that, for example, all right, let's go down here. you can change a couple things, like for this one here, for example, that's the other math teacher's class, Temer, gosh, I still can't say her name. So, but you can change what this says here, which I find helpful. I like to write down like what days the class meets and maybe what time. I don't actually know what time it is. I'm going to make up a time. Let's say it's 10 to 11. Or maybe what room it meets in. So you can change the names in Canvas, the nickname in Canvas anyway, to be something that might be more helpful or useful in case you want to do that. I like to do that, especially like for the actual classes I teach here. You'll notice I've written down the names and the times right there because I find that useful. I think that's it. Canvas. Anyone talking about grade scope? Is he doing anything? No, he's not doing anything in grade scope. Okay, cool. Some people use grade scope. Oh, okay, sure. Some people do not. It's usually a way of like just submitting your work. Let's do a new share here. Man, I really hope I'm recording volume here. We're gonna find out later. All right, let's get this set up. Question, yeah.
Do you know what his final project is?
I do not. That's a good question. I do not have an answer to that. But I'm sure we can find. So let's actually, since almost everyone is in Tab's class, let's take a look at his Canvas real quick. Let me make sure. Gosh, fun times. Yeah, I can just share the screen. Sure, let's do that. Sorry, I know this is all. Let's see. So let's go to Tavernetti's class here. Where are you, Tavernetti? There you are. It might not say. Oh, but I heard some of you talk about like where to find the homework for his class. I went to Pages, I think. Maybe not. Syllabus, outline lecture notes, exams, practice exams. That seems like none of those things are there, but let's take a look at all of them.
I got it.
Okay. So there's a syllabus. Yeah, all that good stuff. Midterms. Where's the thing about you said there's a final project?
In the breakdown of grades. Project.
Interesting. I wonder what that is. It's possible that might be something he had as a carryover from last time we taught the class, because certainly earlier my name was not in there and someone else's name was in there. I don't know. Let's see. Let's go back to Pages. Said this one here. Let's take a look. So here's where you can find the homework right there. And apparently the class notes as well. And not a whole lot else yet. If we look here, I don't know. I mean, he would probably know best. So you might ask him. It's probably not too big a deal. Oh, that's not where I want to go at all. Okay, sure. But yeah, I don't actually know.
Because yeah, it says projects in the grading. It says projects 5%, midterm 60.
Okay. I don't know. Let's see if we can get this looking less than. Okay, we'll try our best here. It's always a challenge. What did I do? Wow, that's amazing. What did I do? Let's try turning it off and turning it on. Did I break it? Let's see here. Sorry. Maybe someday. Let's try that. Okay, doesn't look wild and crazy. Wonderful. That's not going to work for me. What is going on? I've ruined it. Let's see. Okay, I think I found the right button. Let's try it again. All right, class is over. I'm just kidding. Okay. One more time. I've never hit this button before, apparently. Almost, that might, I mean, black and white's not terrible. I feel like I don't want to press my luck here, but. Sepia. That looks normal-ish. Okay. Let's close that. Let's do that. Let's move that over here. All right. Grab some paper. I should have the paper. So a few things about. All right, that's going to be interesting. One thing I should say is if I get off screen, you should let me know. I try my best not to, but I'm not always great about it. So right as much as possible here. Yeah, interesting. Okay. So, oh, what was I saying? I was saying something. Oh, by the way, you should call me James, but if you don't want to call me James because I'm your teacher, I totally get it. You can call me Mr. Parmenter, which sounds weird. Or if you like saying professor, you can use that title. I'm not a professor, but people are comfortable saying it. So you can call me teacher, you can call me James, you can call me Mr. P. Don't call me Mr. P. But if you really want to, that's fine. All right. So yeah, I guess we should start at the very beginning. Let's talk about plotting, graphing, stuff like that. So it's Co-16A, date is September 28th, 2023. Plotting stuff. In fact, let's grab some graph paper here. Just because it's a little easier. So just so that everyone's on, can you see that all right? That's less than excellent. Let's just do away with that. Sure. So let's plot some points. Like the point 2, 3. So when we're plotting points on the X, Y coordinate system, the first coordinate is X, the second coordinate is Y. If the first coordinate is positive, it means you're moving right. First coordinate is negative, it means you're moving left. Second coordinate is Y. If it's positive, you're going up. If it's negative, you're going down. So if I'm going to the point 2, 3, I'm going 2 in the X direction and 3 in the Y direction. And let's call that A just to make it easy to label. So there's point A. Or we could say, let's say B is the point -4, 0. So I'm going 4 to the left and 0 up or down. So I'm just on the x-axis. And you can graph C. Let's say C is 0, 2. So 0 left or right, 2 up. All right, I'm gonna have you plot 3 more points. D is 3, -1. B is -2, -4. And F is going to be, sure, -3, +2. Plot those 3 points. I don't love this here. I'm going to move that up top. It should look okay. Screen that just a little bit. And just because people often ask, yes, you're welcome to take pictures whenever you want. I will mention I am going to post these specific notes on Google Notes not long after class. Sometimes it takes me a little while depending on if I have other stuff to do. Like I don't remember actually. I don't know what I'm doing after this, but eventually I have another class each day. But eventually by the end of the day, they'll be available. So again, if you like taking pictures of, totally fine. Let's plot them. So 3 right, 1 down. So 1, 2, 3, down 1. There's D. And then 2 left, 4 down. So 1, 2, 1, 2, 4. And 3 left, 2 up. So there, we have plotted some points. One observation I would like you all to make is that this point here on the y-axis, C, which coordinate is 0? X or Y? Right. And for this point here on the x-axis, B, which coordinate is 0?
Y.
Right. And that is typically how we go about finding x and y intercepts. If you're trying to find a y-intercept, x has to be 0 because you haven't moved left or right. Similarly, if you're trying to find an x-intercept, y has to be 0 because you haven't moved up or down. Cool. Let's see where to go next. Oh, I had a whole thing. One sec. Let me find my. Sorry, I'm a little scattered here. Sorry. Sure. Yeah, there's so many things to say. Let's talk about distance for a second. Yeah, distance. Yeah. So distance between points. So to find the distance between 2 points, it's really just an application of the Pythagorean theorem. So for example, let's say we'll find the distance between, let's make it not too terrible, 1, 2, and 4, 7. And normally you wouldn't need to draw a picture for this, but let's draw a picture to see kind of what's going on here. This could be higher. I mean, it can't actually be higher, but it would be nice if it was better. I didn't give myself enough room, but that's all right. Cool. So 1, 2 is right there. And 4, 7 is right there. What we're really going to do here is we're going to draw a triangle. So I'm going to go like this, and like this. And I'm going to note here that that point right there has the same y value as 1, 2, right? Because I haven't moved up or down from it. So the y coordinate there is 2. And the x coordinate there is the same as the x coordinate there because I haven't moved left or right from there. So that's 4. And now I'm going to point out that this distance from that point to that point is just 3. Right, from 1, 2 to 4, 2, I've just moved 3 to the right. Similarly, from 4, 2 to 4, 7, how much have I moved up? Right. So then if I want to find the actual distance between those 2 points, well, I can use the Pythagorean theorem for this right triangle and say that 3 squared plus 5 squared is equal to the distance squared. Or more generally, the hypotenuse squared. And so if I want to find the distance, okay, I'm just going to take the square root of both sides. Now, I want to point out here, the square root of 3 squared plus 5 squared is not 3 plus 5. I can't just square root each part individually. All I can do is say square root of this side, square root of this entire side is equal to the square root of that side. So that's the square root of 9 plus 25. The square root of distance squared is just distance. And then finally, the distance is the square root of 34. And that's just what it is. There's nothing better to write here. You could break out a calculator and figure out it's approximately 5 point something, but we don't want that answer. Nobody, unless they specifically ask for it, is looking for a decimal approximation. So if your answer is a radical, you should leave it as a radical unless someone says, give me a decimal approximation. To be a little more general, okay, sure. To be more general here, the way we actually calculated this is we said that the distance, so here's the more formulaic way of doing it. is the square root of the difference in the x's squared. So 4 minus 1 squared plus the difference in the y squared. 7 minus 2 squared. That's exactly what we've got right there. It just looks a little different. The general distance formula so the distance between the points x1, y1, and x2, y2 is given by the formula distance equal to the square root of, again, I'm just going to say the same word, thank you, and write different things. The difference in the x's squared plus the difference in the y's squared. And it doesn't actually matter which order you subtract them in. You can do x2 minus x1 squared plus y2 minus y1 squared, or you can do y1 minus y, or sorry, x1 minus x2 squared plus y1 minus y2 squared. Because either way, if you subtract things in the opposite order, you just get the negative of what you would have had. But then when you square it, it doesn't matter. 3 squared and negative 3 squared are the same thing. They're both 9. I guess since we're already here, we might as well talk about circles. Okay. Also, you really should, if you have questions, you really should ask them. Like I know this, like for a lot of people, like, yeah, I've seen this before, no problem. But maybe not everyone's seen this or doesn't remember it very well. So if you have a question or a comment, or just like I've done something that needs a little bit more explanation, I'm perfectly happy to say more words, as you might have noticed. Okay. So circles. Circles are really just the distance formula again. So what is a circle? It's a good question. It's a set of points. It's a set of points that are all the same distance from the center of the circle. So a circle is just a set of points. Equidistant is the word we like to use from the center. So here's what we're going to do. We're going to write the equation for a circle. The center is, let's say, 1 comma negative 2, and whose radius is 3. And we'll draw a little picture. Yeah, in fact, let's draw it because I want to show you how I would recommend drawing a circle generally. So first draw the center. Over 1, down 2. And if I'm drawing a circle, the radius is 3, I'm going to go 3 in each of the 4 directions. So 3 left, 3 right, 3 up, 3 down, because that's the easiest way for me to draw. So I go 1, 2, 3 up. 1, 2, 3 to the right. 1, 2, 3 down. Maybe I went too far right. It's okay. 1, 2, 3 to the left. So these are what I typically call the 4 corners of the circle. I know circles don't have corners, but it's the easiest way to say it. And I think I went a little too far right there, but that's okay. Circles don't have to be perfect. Sure. There's my circle, whose center is 1 comma negative 2. And we could label these points here. We really don't label these points there, but you could if you want to. So how do we find the equation of the circle? Well, when we talk about the equation of a graph, it's really just an equation where any point on the graph satisfies that equation. So this point here, x comma y, and this point here, x comma y. What do all these points on the circle have in common? Exactly, they're a distance of 3 from the center. So I know, for example, that this distance right here must be 3. Great, let's use the distance formula. The distance formula says that the distance between x, y, and 1, -2, well, just like before, it's the difference in the x's. So x minus 1 squared plus the difference in the y's squared. So y minus -2 squared. And we actually know that that distance is equal to how much? Right. So now all we're going to do to make this look more like the way a circle equation is actually written is we're going to square both sides. So we're going to square this side. So I don't like doing it. So I would normally not take this additional step, but that's fine. Let's write this as y plus 2 squared equal to 3. And now we're going to square both sides. And then we're just going to get x minus 1 squared plus y plus 2 squared equal to 3 squared, which is 9. And this is the standard way of writing the equation in a circle. We wouldn't multiply this out like you could, right? This would be x squared minus 2x plus 1, and this would be y squared plus 4y plus 4, but you don't want to multiply that. Kind of like you don't want to write the equation of a line in the point slope form when you can write it in the slope intercept form because it's more informative. This is the most informative, nice way of writing the equation in a circle. This is the standard equation of a circle. Excuse me. What I would point out here is from this equation, you can immediately read the center and the radius. The center is the x and y value that make each of these equal to 0. So x is 1 because 1 minus 1 is 0, and y is 2 because -2 plus 2 is 0. Sorry, y is -2 because -2 plus 2. Finally, the radius is the square root of 9, which is 3. Something else I want to say here. Oh, I know what it was. Something interesting. The center of a circle is not actually part of the circle. It's important and useful to know about, but the center of the circle is not a point on the circle. The center, if you plug in 1 here, in fact, let's plug it in. If I do 1 minus 1 squared plus -2 plus 2 squared, what's 1 minus 1? What's -2 plus 2? And if you square that, still 0. 0 plus 0 is. And is that equal to 9?
No.
Definitely not. So the center, although super important and useful to know about, is not actually a point on the circle. There are actually lots of graphs that have important points that aren't like points on the graph. A parabola is another example of such a graph. There's a point on the parabola called, or not on the parabola, there's a point having to do with the parabola called the focus, which is like in the parabola that well, I don't want to get into the definition, but it is an important point. It's kind of like if you scream into the parabola, your voice would bounce off of it and go towards where the focus was. Circles. Yeah, let's talk a little bit more about circles. So often people will say something like, write the equation, yes, of a circle with center 0, 5 and radius 2. In fact, you should try that. I should say the standard equation. All right. So usual process here. We're gonna say it's x minus the x coordinate squared plus y minus the y coordinate squared equal to the radius squared. Now, I would not feel good about leaving my answer like this. X minus 0, we should just write as x, because anything minus 0 or plus 0 is just itself. So I should really write this as x squared plus y minus 5 squared equal to 4. That is how I would like to write the answer here. I suppose I probably should have maybe already given you the standard equation of a circle with usually the general rate or center they give you is a center of h comma k and radius r is exactly what you think it would be. Instead of using 0 and 5 and 2, we're going to use h and k and r. So it's going to be x minus h squared plus y minus k squared equal to r squared. So really, once you're given a center and a radius, you can just kind of plop those values in for h and k and r, and then you've got the equation. And depending on what your r is, you might just leave it like, let's say they said the radius was like, I don't know, something we did just like 351. I'm not going to find the 350. I'm just going to write it as 351 squared. Like no one needs to find out what 351 squared is. Is there anything else to say about? I mean, there's lots to say about circles. Is there anything else important? Sure. Someone could ask you to go the other direction. Meaning instead of saying I gave you the center and radius and ask you for the equation, I could give you the equation and ask you for the center and the radius. And there's two varieties of that. So let's do the first variety. So given x minus 3 squared plus y plus 2 squared equal to, let's make it spicy, 23. Tell me, write down the center and the radius. And yes, if you do need to leave early, that's totally fine. I understand people have conflicts. They might have another class that starts at 10 or 10:30, and they're like, it's all the way across campus. It's really, really okay to leave without like asking me or letting me just like take off. It's fine. Okay, so the center here, x needs to be positive 3, y needs to be negative 2. Again, I always think of it as just the values that make the left side equal to 0. 3 minus 3 is 0, and negative 2 plus 2 is 0. The radius here is less nice than usual. The radius is just the square root of 23. Nothing else to do about it. All there is to it. Usually, this is how someone is going to write the equation of the circle because it's nice. However, someone can give you the equation of the circle in the general form. So this is the standard form. This is the general form. Like x squared plus 4x plus y squared minus 6y equal to, sure, 7. Does not look like your usual equation of a circle. I'm going to tell you something right now. The radius is definitely not the square root of 7. Because it's not written yet in the standard form. So the way we fix this is by writing it in the standard form by completing the square. So we take their x's and their y's and kind of break them apart. I usually like to do this. X squared plus 4x plus blank plus y squared minus 6y plus blank. And on the other side, I'm going to also add whatever I add on the left side, because if you add something on the left side, you need to add it on the right side to maintain the equality. So what do we add? I know it's maybe been a while since you've completed the square. It feels weird to complete the square to find the equation of a circle, but so here's what we do. If you've got x squared plus something times x, you take the coefficient of x
divided by 2. So we're gonna have 4 divided by 2, and then square it. 4 divided by 2 is 2, 2 squared is 4. It always feels weird when it's 4 because you just are getting back 4. Okay. Same deal for the y squared. Oh, if I added 4 here, I should add 4 here. Same thing for the y squared minus something times y. We're going to take the coefficient of y. And I do think it's worth paying attention to the sign here. That's a -6 divided by 2, which is -3. -3 squared is still going to be +9, but it's nice knowing that was a -3 because that's actually going to help us factor it the right way. And then I'm going to add 9 over here. Cool. So why is this called completing the square? Well, because now both the thing with all the x's, well, I didn't leave myself a good amount of room here. Oh, well. This part here is just something squared. It is x plus 2 quantity squared. And I know it was plus 2 because 4 divided by 2 was 2. Similarly here, I'm going to have something squared. Y, what comes after y? -3, exactly. The -6 divided by 2 gives me the -3. And you can check if you want by actually foiling it out. Y -3 times y -3 is y squared -6y plus 9, which is exactly what we have up here. So that's why it's called completing the square, because you're literally making so you can write it as something squared. And then on the right hand side, 7 plus 4 is 11 plus 9 is 20. So here my center is -2, +3. And my radius is the square root of 20. Which I would probably leave as is, but if you really want to, you could simplify it a tiny bit and write it as the square root of 4 times 5, which is 2 times the square root of 5. Sometimes people like to simplify things like that. I don't think it's super necessary. All right. Time is it? Okay, we got 20 minutes. Enough about circles. Let's talk about intercepts, and then we'll talk about lines. Yeah. So, intercepts. Finding intercepts. It doesn't matter if you're talking about lines or any kind of function or not function or circle or graph. If you want to find the intercept or intercepts, the process is always the same. So let's look at an example here. Sure, let's say our function is, let's say, where's my examples here? Sorry. Sure, let's say we've got y equal to x squared minus 4x minus 5. And well, actually, let me ask real quick. If I were going to graph this, but I'm not, what kind of shape would I get? Starts with a P. Yeah, and we know it's a parabola because we have a quadratic equation. At the highest power of x is 2, and all the other powers of x are positive, or I should say non-negative, right? It's a quadratic polynomial. But I don't care about that one. I just want to find the intercept. So to find the y-intercept, we're going to do what? Well, if we're on the y-axis, what has to be true? Right. X has to be 0 all the time if we're on the y-axis. So we're going to set x equal to 0. Usually, if something's written as a function where it's y equals a bunch of stuff, usually finding the y-intercept is easy because a lot of the things just go away. So if set x equal to 0, we're going to get y equal to 0 squared minus 4 times 0 minus 5, which feels a little silly to write out, but that's fine. 0 squared is 0, 4 times 0 is 0, 0 minus 5 is minus 5. So I will mention here, if you're actually writing the intercept, though, we usually write it as a point, which means an ordered pair. So our y-intercept should be the point 0, comma, -5. But sometimes people are just going to say y equals -5. The x-intercept, or intercepts, because you can have more than one x-intercept if you've got a function of y, a function of x. Same idea. We're going to set y equal to 0. Which usually involves a little more work. Totally fine. So I do that, I'm going to have x squared minus 4x minus 5 equal to 0. And depending on what's going on, you're going to use whatever method you have available to you. Usually, if it's something that's not linear, you can't just solve for x, you're going to have to factor. This does factor, I think. Well, if it didn't factor, we could use a quadratic equation, but I believe this factors. We can multiply to -5 and add up to -4 with a -5 and a +1. That works out, right? Because we've got a x squared and we've got a -5x and a +1x. And 1x minus 5x is -4x, so that works out all right. And then you can skip this step eventually, but if you're not sure, or I should say, I should remind you, when you have two things that multiply to 0, and only 0 is the only thing this works for, what does that mean? Yeah, but that means that one of the factors, or either of the factors, has to be equal to 0. Like the only way things multiply to 0 is if one of them is 0. Not true for other numbers, right? You can multiply to 8 in like literally an infinite number of ways. I know 2 times 4, 1 times 8, 16 times 1/2, 32 times, right? There's literally an infinite number of ways you can multiply to anything other than 0. But to multiply to 0, and that's why 0 is special, one of the factors has to equal 0. So you can take the longer way and say, oh yeah, x minus 5 equals 0, or x plus 1 equals 0, and that'll lead us to x equal to 5 and x equal to -1. So our x-intercepts would be 5, 0 and -1, 0. So I want to emphasize that because I've seen a lot of people in the past write something like something times something equals 7, and then say each part equal to 7 and get wildly wrong answers. So make sure you're not making that mistake. But the only way you can set each part equal to the thing is if you're multiplying to 0 and you're setting each factor equal to 0. Cool.
Bless you.
Thank
Sure, we can do one more.
So let's say we have this interesting looking problem. Let's say we have y squared equal to x cubed minus 9x. And again, we want to find the, I have another cool problem. I've got 2 more cool problems. Sure, again, we want to find the intercepts. Same process. I usually like to start with the y-intercepts because they usually feel easier. So I'm going to set x equal to 0. I'm going to get y squared equal to 0 cubed minus 9 times 0, which is 0. So if y squared equals 0, what's y equal to?
0.
Right. Now, I will point out, you could do a little more work. You can say y equals, if you really want to be everything, plus or minus the square root of 0. And the reason I'm saying this is mostly just so I can remind you all that square root of 0 is 0, just like the square root of 1 is 1. Right? Square root of 0 is 0 because 0 times 0 is 0. Square root of 1 is 1 because 1 times 1 is 1. Square root of 9 is 3 because 3 times 3 is 9. But here, square root of 0 is just 0. So y equals plus or minus 0, but plus or minus 0 is just 0 because 0 is the only number that's its own negative, or alternatively, the only number that is neither positive nor negative. The only real number that is neither positive or negative. Imaginary number is, there's not really a concept of positiveness and negativeness, but we're not talking about imaginary. So x-intercepts, we're going to set y equal to 0. And we're going to get 0 equal to x cubed minus 9x. And once again, we're going to factor because it's not linear, right? We don't just have x to the first power, we have other powers of x. So factoring here, first I'm going to factor out the greatest common factor, which is x. So I'm going to get 0 equal to x times x squared minus 9. You could just set each part equal to 0 now and be fine. I'm more of a fan of fully factoring if possible, especially for later on when you start graphing things like this. If I was going to graph y equal to x cubed minus 9x or y squared, it's helpful to fully graph it because you kind of see what the intercepts are going to do. So I would do, it's helpful to fully factor it so you can see what the intercepts are going to do. X squared minus 9 is a difference of squares and it factors as x minus 3 times x plus 3. So we can see that we're going to get x equal to 0 as an intercept, x equal to positive 3 as an intercept, and x equal to negative 3 as an intercept. So if I was actually writing them out, I would say my y-intercept is 0, 0, and my x-intercepts are 0, 0, 3, 0, and negative 3, 0. I want to give you one more like this because I saw it in the homework. Or that's not true. I saw it in the section of the homework that you were assigned, and I don't know if it actually got assigned, but it brought up something that I thought was worth addressing. So let's look at one more example like this, and then we'll try to graph a couple of lines. Let's say we're looking at, y equal to, sure, x squared minus 25 over x minus 5. Let me ask you all a quick question. What is for sure out of bounds for x regardless of whatever happens? What is x not allowed to equal? 5. 5 is a problem, right? If x is 5, you get division by 0. Specifically, actually, here you get 0 over 0, which is even an extra challenging story. But it doesn't matter if it's 0 over 0 or 7 over 0. It's still undefined. We're going to see a lot of 0 over 0, though, as we start talking about limits and all kinds of stuff. But so just prepare yourselves. But here, if we're just trying to find intercepts, usual story. So intercepts. We want to find the y-intercept. As usual, we're going to set x equal to 0. We're going to get y equal to 0 minus 25 over 0 minus 5, which is negative 25 over negative 5 is positive 5. Great. So our y-intercept is 0, 5. X-intercept's a little bit dicier. But we're still going to start off the same way. We're going to say 0, setting y equal to 0, is equal to x squared minus 25 over x minus 5. Usually when you're trying to solve some sort of rational expression, aka a fraction, equal to 0, you just multiply both sides by the denominator. Or in other words, you set the top equal to 0. Right? If I multiply both sides by x minus 5 times 0 equal to x squared minus 25 over x minus 5 times x minus 5. The x minus 5's cancel here, and 0 times anything is still 0. So I'm left with 0 equal to x squared minus 25. And then if I solve for, I guess I could factor. I like factoring. 0 is equal to x minus 5 times x plus 5. So what are the possible values for x? It's okay to say both of them. Right, 5 and negative 5. But we already said x couldn't be which? Right, so 5 is out of bounds right off the bat. So really, the only x-intercept we're getting here is x equal to negative 5. So our x-intercept is going to be negative 5, 0. To talk a little bit more about this story, because I think this example is useful, let me show you something. So if we actually look at this function, y equal to x squared minus 25 over x minus 5, we could simplify it. We could write this as y equal to x minus 5 over x times x plus 5 over x minus 5. And then we can cancel the x minus 5s and get y equal to x plus 5. And now I have an important question. Are these the same? Not exactly. Because this function here, x could totally be 5 without an issue. Right? 5 plus 5 is 10, y would be 10. Whereas here, 5 is a problem. So the difference here is that here, x can't be 5. And since that's part of our domain restriction, that carries throughout the problem, even if we cancel the thing that was making it a domain restriction. So over here, we also have to say, oh yeah, x can't be 5. So if you were going to graph this, if I was going to graph the line y equals x plus 5, I would usually graph the line by finding the x and y intercepts, which we actually just found, right? The y-intercept was positive 5. The x-intercept was negative 5. And we draw our best line ever. But what we have here, whoops, it's a straight line, I promise. Kind of. Right? If we're graphing y equals x squared minus 25 over x minus 5, it looks like the line y equals x plus 5, except x is not allowed to be 5. So we're missing this one little point when x would have been 5 and y would have been what? I heard someone whisper it over there. If x could be 5, what would y be? Yeah. What we have there is a hole. That graph is missing 1 point because x is not allowed to be 5. But everywhere else, this looks exactly like the line y equals x plus 5. It's just we just plucked out the point when x is equal to 5. This is a pretty important concept. This is where we're going when we start talking about limits, be like, oh yeah, we're going to look at something like this. We're going to be missing a point. We're going to say, oh, well, I don't really care that that point is missing. If someone asked you for this function, what's happening to the graph, meaning the y value, as x is getting closer and closer and closer to 5, we would say, oh, well, as x gets really, really close to 5, the y values get closer and closer and closer to what? Right. That's the whole idea of a limit right there. As x gets close to a certain number, what is the y value getting close to? It might not actually exist, right? Y is never equal to 10 on this graph. But the limit as x approaches 5 of this function is 10. Kind of neat. Okay. Sorry. What time is it? 10:13. Okay, let's graph at least a couple more points. I know that wasn't really a line. I'm pretending like it was. So graphing lines, typically not too terrible. There's lots of ways you can write the equation of a line. There's the standard form, like y equals 2x minus 6. Y equals mx plus b form. Your book talks about graphing a line by like finding the y-intercept and then using the slope to find another point. I think that is not the best way to do it. If I were graphing a line, I would always graph a line by finding the x and y-intercepts. Unless the line was vertical and only had an x-intercept, or horizontal and only had a y-intercept. Other than those two corner cases, if your line has a non-zero defined slope, you should find the equation of the line or the graph line by finding the intercepts. So process is straightforward as ever. Y-intercept, we set what equal to 0? Yes. I really want that to be like just bedrock solid because you're going to do it so many times to find it. Like y-intercept all the time. Set x equal to 0. Great. The nice thing about the standard form here is that the y-intercept is immediately obvious. If x is 0, y is going to be 2 times 0 minus 6, which is just negative 6. Similarly, my x-intercept, I'm going to set y equal to 0. So usually a little more work. 0 equals 2x minus 6. Add 6 to both sides. Divide both sides by 2. So my x-intercept is 3, 0. Here's what I would recommend if you're graphing a line and you're not given graph paper or some sort of like predefined area to do it. I know I've been making those little marks on my XY axis. I don't usually like to do that. So I'm looking at this here. My y-intercept is -6, my x-intercept is +3. So I'm more down and I'm right, but I'm less right. So I'm going to kind of just eyeball and be like, okay, well, that looks about right. And then try and draw the line like that. Perfect. And now, after I've done that, label the points. Yeah, it's kind of cheating. Nobody cares. That is how I would always do it. Instead of trying to be like over 3, down 6, 2, 4, and then probably missing. I did okay, but right. But it's harder to do it that way, in my opinion, right? Like I would just draw the line about right and then label the points after. I think that's an easier way of doing it. If you don't have like graph paper with grid marks already on it. Alternatively, you could use a ruler to draw a straight line and try and hit the points perfectly. I think I have a ruler. I do, yeah. Nice to have a little ruler. I find it helpful. You can also use like your phone as a straight edge, or an ID or a credit card as a straight edge. You've got something. How much more time? Cool. There's something else. Oh yeah. I should say two more things. Let's find the equation of the line that passes through the points. Let's say 2, -5, and 4, 3. So here's my rule of thumb. To find the equation of the line, you need two pieces of information. Specifically, you need the slope and you need a point. We've got more than enough points, but we need a slope. The way you find the slope between 2 points is, you use the slope equation. Yeah, so the slope is, there's like 5 different ways to write it. It's the rise over the run. It's the change in y over the change in x. But the actual equation is typically written as y2 minus y1 over x2 minus x1. Or if you prefer, y1 minus y2 over x1 minus x2. Difference in the y's over the difference in the x's, you do have to make sure you get the order of subtraction the same. Meaning it's got to be these minus these or these minus these. But we can't do like 3 minus -5 over 2 minus 4. That would be a problem if we had the y subtraction in the opposite order as the x subtraction. So here our slope is going to be, let's do these minus these, 3 minus -5 over 4 minus 2, which is 8 over 2, which is 4. I will point out, if you subtract it the other way, if you do -5 minus 3 over 2 minus 4, it should come out the same. -5 minus 3 is -8, 2 minus 4 is -2, and -8 divided by -2 is +4. Either way you slice it, you're going to get the same slope as long as you do it the right way. And then there's 2 good ways to find the actual equation line. My preferred way is to use the point slope form, meaning I'm going to write y minus the y coordinate equals the slope times x minus the x coordinates. Pick either x, y coordinate you prefer. I usually like using positive numbers if I can. So I would write y minus 3 equals 4 times x minus 4. And then typically people want you to solve for y here because it's the standard way of writing the equation of the line. So I would distribute that 4, say y minus 3 equals 4x minus 16, and then add 3 to both sides and get y equal to 4x. -16 plus 3 is -13. Or if you don't like that, you can start off with y equals mx plus b, where your slope is 4, and then plug in either point and then solve for b. If I plug in, let's use the other point. So y is -5 and x is +2. 4 times 2 is 8. -5 minus 8 is -13. Oh yeah, b is -13. The thing I don't love about doing it this way is then you have to go back and actually write the equation of the line still. So then I'm going to, okay, that's going to give me y equal to 4x plus -13 or -13. Either way is totally fine. I like doing it this way. If you like doing it that way, it totally works, doesn't matter. Either way should get you to the right place. All right, it's 10:20. Let's stop talking. Nice meeting you all. I will see you all on Tuesday, same time, same place.